So let's get started. We're missing one, but it's okay. I'll get started anyways. This week, we're going to talk about animations. Daniel, I know you wanted to hear about animations, so I will ask you a lot of questions to answer a lot of questions. But cool. Actually, before this, I want to make a few announcements. April 15th. December, this is way too many months from now. April 15th is our demo day. We are going to have you guys set up booths where you guys will present your project, and then I think there's also going to be a presentation as well. Is that right, Tree? I don't know all the details, but April 15th is our demo day. So that's something you guys should look forward to. We will give you guys time to set up. You guys will actually have the time to actually go over and run through your presentation. But there's going to be corporate sponsors there. They'll come by and talk with you, and we want you to present to all of them. So you guys should be really excited about this. Demo Day is one of Coder School's biggest events, and hopefully this one will be even more awesome because Andrew is going to dominate, right? So, okay. The other thing is hackathon. We decided to schedule a hackathon on April 7th. So let us know if that's possible for you guys. But it'll be April 7th to April 8th. This is not mandatory by any means, but if you guys haven't experienced a hackathon before, it's really, really exciting. I didn't do my first one until 4 years ago, and it's the atmosphere is just awesome. We will send out more details, but we're kind of curious how many people are interested in going to that. 7th? No, yes, maybe. 1, 2, 3. 1, 2, 3. April 7th? No? Okay. Okay, cool.
Question.
Yeah.
Do we have time to finish the project until April 15?
We will have our internal demo day. That's internal demo day. The end. Tree, is this correct? The last week lab, right? That will be our internal. That's our internal demo day. But you have until the 15th. You have all the time you need until you start presenting to fix it, to fix everything. Or to do everything that you want to do.
We can still continue.
Yeah, of course, absolutely. That's the best part. You guys do an internal demo, and then people give you feedback, and then what you guys do is you continue to work on it through and just keep making improvements. Hopefully, you guys will do things like create interesting videos and stuff like that as well. It's a slightly different format this time compared with previous demo days, but it's still something I think that would be cool for you guys to do. Okay? All right. Cool. So let's dive in and start talking about animations and gestures. So first of all, the thing I'm going to slightly change from our curriculum because what I would normally do is just open a new project and just start coding. But I feel that if I just go and do that right now, you guys won't be I'll just literally be telling you how it works, and you guys will think that's just how it is. So I actually want to take 5 to 10 minutes and have you guys talk about animations. So what is an animation and why? So the reason why I'm doing this is because when you guys are dealing with views, right, and simply making assignments to properties and stuff, that's simple. You didn't really have to know what was happening in the background, right? You didn't have to necessarily understand how things were drawn on Android, because the abstraction is how it's presented to you, so you don't have to know it. But I feel like animations is actually really different because it requires so much knowledge on what's underneath to do animations properly, right? So what I want you guys to do is spend 5 to 10 minutes, and let's start off by having you guys tell me let me create like a new note. Sorry. Okay. I want you guys to basically, yeah, sort of tell me what you guys think, or how do animations work? First of all, describe that. Can anyone describe animations? We have someone that I will default pick this time. Daniel? Can you?
I don't know much about animations yet.
Okay.
But I think it's like a sequence of frames, basically like a movie.
Right. That's a really good way of describing it. A sequence of frames, right? And so usually, like one thing that you're trying to do is you're trying to move something in your view from one location to the other, or you're trying to do something to that property that changes across what? Across what?
The screen.
Across the screen, across, even more importantly, time, right? So our biggest element is actually, so what are some animation properties, right? So time, right? What else? What else? So you're moving. You have these keyframes and it's like you're moving something from, let's say you were talking about like translating, moving an object from one part of your screen to the other. Like, describe that for me. Like, what does it look like? Is it the same speed? Is the delta per frame the same?
Maybe sometimes it's landing, sometimes not.
Right, so you can have different speeds, right? Right, you can have things moving quicker or things like changing through as you move from one initial state to the end state. So one of the things I want to emphasize right now is the specific thing that we're talking about is actually called tweens, right? Because we're talking about animating a single thing from one location to the other. So it's clear, like it starts from one state and it ends at another state. And so that there's actually a definition, a word that's used in industry called tweens. So this is called a tween animation. Okay, you're animating between two states. Okay, that's why it's called tween. But yeah, so you have time, and then so for example, if things are moving linear, what's changing? What's changing? So right, if I'm working, so let's say we're talking about like a translation, right? Then what the value that's being changed is the position, right? And that position, what we're going to see is across time, like basically as you get each frame, it's not going to move like the same distance every single time. It will potentially, well, linearly it would, but potentially if it moved faster, like if you want to accelerate, you would see every single keyframe or every single frame would be further and further and faster, right? Because you're accelerating, right? Or if it's slowing down, it gets smaller and smaller at that delta, right? Does that make sense? Okay, but here's the key. This is why I'm talking about this, because it could be anything, right? What else could change? For translation, it's position. What else can change?
Transform.
What?
Transform like the sign.
Size, right? Size can change, right? So that's like your dimensions, right? What else can change?
Rotation.
Rotation, right? And that's like degrees, right?
Speed.
Speed is interesting because it's actually okay. Well, we'll talk about that, but it's not actually color. So RGB. What else? Alpha, right? Transparency. Oh, sorry. Okay.
Text.
Okay. So what I want to be very focused on here is that, so, I've learned animations before. When I first learned animations, I simply learned it as, okay, I'm just specifying two states and it will animate between them. But what you're going to start to see is why Android created the abstractions that they did, right? So what we're seeing is that all these properties can change. What they are, they're just values, right? But what's key here is this time element. That's the thing that's the interesting part, because what's hidden from you guys in Android is what? You guys don't know like how often like they're refreshing the screen, right? If they say they're refreshing the screen at whatever 60 hertz, meaning like or 60 frames per second, right? When you guys are working in the Android frame, when you guys are working in Android, you guys don't really know that, right? Because you're simply saying, oh, I have this view, I want to display this view with this text. But animations, like what they do is they basically hook into that refresh rate and say, okay, do you have enough time to show a frame? And then they say, okay, give me a frame. What is the delta between the last frame and this frame, time-wise, right? So that's the most important thing here, is that basically Android generates keyframes where they basically hook into the drawing mechanism, right? The clock for how often you refresh the screen, right? So actually, this is important because if you ever create your own animation library, which is something I actually did, I had to rewrite it so many times because I was like, oh, it makes sense. I'm hooking into the screen drawing frames, and I'm basically pulling and getting a time delta for each one. And then from there, I'm calculating values, right? And so that value can conform to some function. And then, does that kind of make sense? So if you want an accelerating function, you would have a function that's like exponential. If you want something that is linear, it'd be linear. If you want one that slows down across time, you create a function. So remember, like, sorry, do you have a pen? Let me draw this out. Right, so if it's linear, your value has some starting point, let's say 0, let's say alpha, and it goes to 1, right? And then when you want it to accelerate, it might look like that, right? Or like that, right? You can also have sinusoidal, right, as well. But the key here is that every single time you move a keyframe, let's say this is K0, K1, K2, you can like look up your function value and come up with the next frame based off of the given time, right? Okay, this is important because you'll see how Android codes it, how we're going to code this up, and I'm going to show you how they did it in the past and why they abandoned it. Okay? Cool. All right, so let's get started. Create a new project, empty activity, finish. Is that making sense, guys? The key is the values, right? How do you hook in to get the time, the delta, the time, and how do you take that time and translate it into a value, right? Right. Does that make sense? The value is what's important because then you can just call set and get regardless. Okay? Okay, cool. So we are going to start today by animating a button. Nothing special. I'm going to drop a button in, and there's no constraints on it. I'm just going to run. Okay? So what I hope you guys can do is, as I'm coding this, you should be able to see the update. Okay? All right. Waiting. I should have started this up earlier. Sorry, guys. Okay, get a button. Top left, right? So let's start. Sorry, let me name this button before we get started. Button animate. Okay. So what do we do? Our usual stuff, right? Find view by ID, r.id, button animate. We're going to cast this into a button. Let me put this up here really quick. Okay, button animate like this. Okay, so what we're going to do is we're going to make it so it reacts on click, right? So when we click the button, it's going to animate. So what do we do? Set on click listener, new on click listener. Okay, cool. So pretty simple. This is stuff that you have all done before. So now what we're going to do is we're going to use something called an object animator. Okay? So an object animator, you basically can select a variety of different values, types of values. Remember, like when we were looking at this, you have like position is like a float, dimensions, probably a float because X and Y, degrees, I guess a float as well. But RGB is like a complex value type, right? A tuple, right? RGB. But basically, if I say, let's say we want to do something that translates position, right? And say a float, okay? Cool. And so we want to the next value is basically the view that you wanted, or the view that you want to animate. So in this case, we have button animate. The property name. So we want to change the value of what? I don't know. Let's say we want to move it down, right? So Y, right? And let's say we want to change it 200 pixels. Okay? Okay? And let me run this. So this, this basically comes back as what? It comes back as a object animator, right? I don't know, move down animation. Okay, let's do that. So one thing that you have to do, well, if I run this, it won't work because you actually have to call start. All right, right? It moved. Let me do it again.
Magic.
Magic. The first animation sells the crowd. Everyone's like,
Magic. Magic.
right, it moves down.
What about if you red?
Yep, it will go down. Or no. In this case, it won't because it's absolute. We set Y. If you want to do, there's another property called translate Y. I believe it's translate Y. I think this behaves differently. I don't know if this. Oh wait, set translates. Yeah, I don't know. Here, let me look at this. Let me see if there's an activity called translate. Button, text view. Yeah, there's basically a bunch of different properties. But right now, like this is not relative, right? This is absolute. Does that make sense? That this setting to Y is absolute. Okay? Okay, but first of all, did that look correct? Oh, sorry. Did that look correct? It didn't move that far, right? That might be 200 pixels, but usually we're not interested in pixels, right? We're interested because we're interested in supporting a lot of screen sizes. We want to have the density, right? So what is it? Get resources, get dimensions, I think it is. Oh, display metrics, density. All right, and that's a float. So we can multiply, right? right? Cool. That looks more like 200 density independent pixels. All right, so now what if we want to do two things? What if we also want to, I don't know, tell me what if we want to move it, we're moving it in Y right now. What if we want to move it X? Yeah, slanted, right? So what can we do? Right, animation, object animator. Again, it's a float, right? Button, animate, X, and let's just make it 100. So it's kind of funny though, right? We didn't really specify duration, no?
Yeah.
Right? By default, there is like a set time or whatever, and you can override it. We'll get to that a little bit later. Okay. Okay, so this is kind of weird though, right? It's calling start and start here. No? That part's kind of weird, right? Like, you want these animations to act together, but calling start and start, right? But, so will this work? You think it should work? It should work this? I'm curious. Yeah, that's a good question. Will it work?
I think it will right now.
It will move down?
Now it right.
Why do you think that? Wrong. Wrong. It happens together. So, again, this is the part that's masked from you, right? Is that, just think about how like threading works, right? Or you have two animations called start. You're thinking it's executing them sequentially. It's not. Remember, the UI thread just is processing messages, right? So it's literally scheduling and saying, for the next frame, please start this animation and start this animation, right? This is happening. These are happening really fast, right? It's basically not. It's pushing this value calculation not to your main thread, because the main thread is meant for like dealing with all this stuff. It's literally just scheduling a message for the animator to start both of them. So it might seem that there might be some sort of conflict here, but there actually isn't, because if you actually look at the underlying process behind it, remember how messages are processed? It's basically like, it's saying, if you think about, again, I'm requesting a keyframe, it's time to draw a frame, what needs to happen? If both animations have been scheduled within that next keyframe, then both of them are going to start at the same time. That's what this start is doing, right? It's not actually saying like run to completion and wait for completion and then run the next one till completion. It's just saying start. Cool? Okay. So what happens if you want to draw the L? Right? You have to basically specify. You have to somehow specify to wait for completion. Right? Yes? Does that make sense? Okay. Well, actually, sorry, before I go into that, does everyone understand what this is doing? Like, remember how I said translation Y or whatever didn't work? You can't find the property, right? So like, does everyone kind of understand what's happening here? Like, how is this working? So remember, Object Animator is just, what it's doing is it's just tying into like scheduling like a keyframe listener almost, right? It's saying, please listen for my keyframes. Please, in this case, linearly, right? Change my Y across the duration, however long it is, from this current position to 200 density independent pixels. And then when I get that value, set Y, right? So this Y is using reflection. It's basically looking in this BT animate, this button, and looking for like a setter and getter. Right? Because it says I have to get my current position, right? And then as I'm animating over each keyframe, set, right? It's just as each keyframe comes in, it's just calling set. So that's why you're seeing that happen. Does that make sense? So do you guys see how little binding there is to the actual view itself? There's almost, it's purely using reflection in this case, right? It's saying I just know I just need to listen to this keyframe and change a value, and when I get that value, I just set that value as a property, right? So we call this in Android property animation. We call it because you're not really it's basically any property on the object. This could even not be a button. It could be some other thing, right? You could literally have the value change as long as you have a getter and setter. Right? Cool? Does that make sense? So remember how I complain a lot about how Android has very tight coupling with their internal systems? This is like one of the things that's like designed like correctly. It's like architected correctly. Like even if you look at, we'll dive into some details, but it's clear, right? When we went over these properties, the only thing you really need to tie into were these keyframes, nothing else. Okay? Okay, so, well, actually, before we do the L thing, one thing that we can do is also change the duration, right? So let's move down animation, set duration to, what, how long? 5 seconds? 5,000 milliseconds, okay? And let's remove this for now, just so we can see what will happen when we add it back in. Alright, so slow, right? So slow. So what other things that can we talk about? Change. We can remember acceleration, right? How fast that value changes, right? So we can say move down animation, set. So we call that interpolation, right? And we can have an or actually let's change it. Okay, so there's like decelerate interpolator. Right? And so what does a time interpolator, right? I guess interpolation. It takes an input, which is, think about it, right? If it were, it's basically taking your time value and then getting a, right? It's looking for this, give me a value. That's all it's doing. But naturally a linear interpolator versus a decelerate interpolator, right? It will do some sort of math, right? Like a linear interpolator, sorry, let's stub interpolator. Oh my gosh, all right. Well, anyways, somewhere it's hidden inside there. Basically, it's just gonna return the value that you get, okay? Okay, so let's try this. And of course, you guys can create your own, right? But it's kind of nice that they have already predefined functions. Get slower and slower and slower, right? Let's make that a little bit faster so that you can get a sense of what that looks like. Right? Kind of nice, right? It's just like it's nice and slow at the end, right? Okay. Okay, so now we want to create the L effect, right? So before you call start, actually I don't know if you really need to do it before start. I imagine you do because of how it schedules. But okay, so move down animation. You can actually set, or I think it's, yeah, basically you can add a listener. Okay, so this listener is a what? Animator listener. Okay, so it has all these 4 properties, right? So I could say animator listener like this, but it's actually not what I want. Instead, I'm going to do adapter. Does anyone know the difference?
Now, adapter when you can one of them.
Right. So this is actually really important. This is actually, so if I look, since you guys mentioned you guys like design patterns, adapter pattern is a very important pattern. Basically, you define an interface, but a lot of the functions in there are optional. It's really important in the case that you're hooking into something, right? You don't if you're creating an implementation of it, if there are optional hooks, you don't want to write the hooks for every single one. So the adapter pattern, actually what it does is it creates a default implementation where all the functions are like empty functions, or they'll throw runtime exceptions, for example, if they're required, but it'll basically create empty function definitions, and then you override only the one that you want, right? Okay? So remember this one. This is good. Okay? Okay, so on animation end, let's copy this and paste this in, right? Whoops. I didn't do density, so let's put final in there. Okay, sorry guys. Nice. You got the L. You got the L. Does that make sense? Okay, but you guys can imagine how problematic this can get, right? Let's say I have like 5 animations that I want to have, and one after the other, right? Or I can have like, imagine you have to you want to change like 10 properties at the same time, right? Like every single time you do it, you're gonna have to call start, right? You're gonna have to define every single one. So Android, what they define on top of this is something called an animation set. So basically, it allows you to create a hierarchy, right? Right. You can basically compose different animations together, and then, like, yeah, basically you can schedule them relative to each other, right? Whether you want them to be played sequentially together, stuff like that, right? It's much better because, and not only that, every single time, let's say I want like 4 animations to happen at the same time, if I change one duration or change the duration, I have to change every single duration. Instead, what you can do is I can say I want these 2 things to happen at the same time with a set duration, right? So it's a higher level of abstraction, right? And the second thing that's most important is that you don't have this. You don't have the chaining. You don't have to add a listener for every single one. And what do we call this? Does anyone remember? This is similar to the asynchronous stuff. Callback hell, yeah, right? That's right. You don't want callback hell. Cool. All right, so let's do that, right? So let's add one more animation in where we're going to change. So we're going to do these 2 together. But we're going to add one more that actually what it does is, well, actually let's change this. So let me remove this listener first. Okay, so then there's something called an animation set. Sorry, animator set. Actually, let me remove this. Animator set. Let's remove the start from both of these. Let's say set 1, okay? For lack of better. Okay, and then set 1, we're going to say play. We want these to play together, right? Move down animation, move right animation. Let's do one more thing. We're going to set duration. Okay, so I'm going to set the duration here first, and then the thing that you have to do is that playing together doesn't mean that it will start. It just means it's really just scheduling these together. You have to call start. You have to actually call start on the animator set, unfortunately. So the other the other one that you can do is what? Play sequentially, right? Okay. All right, ready? It's gonna be beautiful. Right? And then let's say play sequentially. Right? But let's say I want to play them together. Remember, it was kind of weird when I played them together because the durations were different. So I can say set 1, set duration to 2000. Right? Looked a lot better, right? So the time was correct, and then you see, I mean, I don't know anyone who's going to animate like in a diagonal format, but you guys are getting the point, right? Okay. So any questions at this point?
When we set the duration for the animator set, it apply for two animators.
For both?
Apply the
Yep.
duration for all the animators.
Yep, that's correct. That's correct. I don't know like what happens if you call set duration on individual ones. For example, if you set, like if I called set here, like set animation, actually I think that makes sense. If I say, okay, let's say I want to change it. Let's say I set duration here. Let's see what happens. I don't know. I don't know what happens if I set like 1,000. I don't know if this one overrides, but we'll see. Let's see what happens. Let's see what happens.
Maybe the set will
Yes,
arrive. What the set is?
Maybe I should. You want to set to 10,000? Okay. All right. running. Nope. It seems to override. Yeah. So it overrides all of them. Right? Cool.
How many animation you can put into set one at the same time?
Together? Yeah. As many as you want. These this is like it takes either a ... or a list, right? So if I say, you can it's the same thing for right. So play together. There's two ones, right? You can have a ... which is infinite number of animators, as well as a list, right? Same with sequentially. Sequentially is one after the other, right? Cool. The other thing that you guys might have noticed when I was typing this out was that of floats, they also has ... So if you actually read what happens here, the first one is, if you specify 1, it's just the end value. Specify 2, start and end value. If you specify more than 2, it is start and then all the things in between. So you can basically, it'll try to hit, like it'll linearly, as time progresses, try to hit each one of those states. And somewhat linearly. You can also add like an accelerate, decelerate thing, which it'll be kind of weird, right? Does that kind of make sense? Cool. Okay, so now let's compose. Right. Well, we can do 10. We can do 10. That would definitely take some time. But okay, so now we've already created one animation set. Now what we want to do is, we want to do these two together, but then we want to create another animation set that fades at the end. Okay. So that will be object animator, fade out animation. Object animator. Again, this is a float, right? Okay, so right now I'm using button animate, but actually on click we have the view, so we can actually change all these to V. Okay, and then we'll change alpha to 0, right? So I can just schedule that straight out, right? And it'll happen all at the same time, right? Fades out, okay? But what we can do is actually wait for it to happen at the end, right? So how do we do that? We basically say animator set. So it's giving really bad names right now. Okay, so we want to play these two together. Set 2. We want to play those together, but then what we want to play sequentially okay, so actually let's move this duration. Sorry, I don't know why I did that, but set duration here. And then for set 1, we will play sequentially. We can take set 2 and fade out, right? So fancy, right? Right? Cool, guys? Looking good? This is the sexy part of developing apps.
Jesus.
Okay, great. But let's be honest, this kind of sucks, right? Every single time we have to write do all of you guys know what the builder pattern is? Everyone knows what the builder pattern is, right? Design pattern. Okay, so I introduced adapter pattern. There's also something called the builder pattern. So also something you guys should look into, but basically this kind of sucks, right? Because it doesn't follow the builder pattern, so you're basically being very verbose. Every single time, like I create a new animator set, I have to play together. I don't think this returns an animator set. Yeah, it returns void, right? So, like literally, I have to say set 2, set 2, set, and then build on top of that. So there's 2 things that you can do to make this easier. One is that Android introduced something that if you're only working on a single view, like in this case, you can actually call animate, and then you can do things like set x, y. You can also do y by, right? So this is actually like every single time you move y by a certain distance. So actually, let's do that. Y by. Let's change this to. Sorry, guys. Then you can also do what? Y by, and let's change this to what? 200. Let's say 200. Rotation, I don't know, 90. And then start. Right? I removed a lot. And you guys should familiarize yourself with the builder pattern. It's actually really important. I do it a lot when I do software engineering, and it's great if you're trying to compose something that requires a lot of different properties or optional properties. You don't want to call set a billion times, right? It looks much better when you can specify them all in one single line, and then at the end you call build. In this case, we call start because we're just going to run it. But right, cool. And it'll happen again because I did rotate. I think I should be able to do rotate by, right? So it basically can rotate by 90. Uh-oh, I think it killed my ADB process. Okay, well, let's see if it runs this time. Android. Dying. Alright, give it a sec, guys. But that's all making sense, right? That's pretty cool. You guys are starting to see the different animation stuff. Did not want to be an animator when I started Android, because this stuff didn't exist, actually. None of it. There was no such thing as object animator. We'll see when we animate activities, how it worked in the past. But again, they had very, very tight coupling with the architecture, not this sort of object binding, right? This very loose object binding. In the past, it had very tight binding, so it was it was terrible. That's why we didn't do much animations. That's why Android initially actually didn't have very many animations. If you had compared iOS to Android really early on, there's a lot more animations going on in iOS than Android because it was just too difficult. You would have to write your own thread, basically. Okay. All right, so rotate, right? Cool. Okay, sweet. So what's the other option? The other option is actually let me save this somewhere. Save this below. Okay. Oops. The other option is to put this into an XML file. Oops. Source directory. So not anim, animator. Because animator is a new one. Okay? For new stuff. Okay? And animator resource, what does this say? Basically, what are we going to do here? We're going to basically regenerate the same thing, right? So it's called regenerate. Okay, so you can start off with a set. Here, you can say ordering sequentially together. So we're going to say sequentially, because inside what we're going to do is create another set that has ordering together, and then we can say object animator okay, so what are some of the properties here? Right? We can say what? Or what do we want to do? We want to basically say X, right? Or I think it was X, right? Property X. Oh, sorry. Value 2, right? Value 2, we want 200 dp. I think its property name is Y. Let's copy this. Copy spaghetti. X 100 dp. And then object animator property name alpha value 2 0, right? All right, let's run this. Oh, sorry. We have to inflate. We have to inflate, right? So along with all this, we have this thing called animator inflator. Loads animator this. Main activity this. R dot animator generate. Okay, so what is this? What does this give me? This gives me an animator. Okay. So, what do we have to do here? The difference between this and this animator set is that the property was already specified here, right? So we can now just set target to v. Okay? It's gonna work, right? It wasn't the same because we didn't add an interpolator. That you can specify here. I think, what is it? I don't remember the exact specify, but there's like a text or resource that you have to specify in order to use it. Okay, so can anyone tell me why you would use this? XML.
Easy to reuse.
Yeah, reuse. Reuse is one. So, for example, if you want to use it in a lot of different contexts, you could do that. Versus like using the view animate is simply for that specific situation. On top of that, you can still do the same thing as different layouts, right? Landscape, right? Remember, like you could create an XML for all the different landscapes. You can do for different sizes, right? Different screen sizes. You can change your animation accordingly. Also, this is also much nicer to read if it gets very, very complicated, right? Because you have all this nested sets. It can be very, very big, and you don't have to sit there and like write everything out. You can clearly see the grouping and the nesting very clearly versus if you were doing this case, right? Because imagine if I have like 10 animation sets, literally it would look like they're all like at the same level given the fact that there's no indentation and all that stuff, right? Does that make sense? Yeah, I would show you guys that, but I guess you guys can sort of just believe that it will work. Like if I switch to landscape, animation will look different, right? Cool. And I think I didn't mention this earlier, but you guys should already know that the coordinate system is like this, right? 0, 0 is on the top left, and then it goes basically out until you reach this screen width, screen height. Okay? Cool. That is making sense for everyone? All right. I forgot what I was going to do next. I know I'm missing something. Hold on, let me try to think. What was I going to do next? Oh yes, I remember now. So this is fine because if the animation basically goes to completion, right? Most animations aren't like that. Most animations, like you're receiving a bunch of touches. And especially if you have a long animation that's like maybe 2 seconds or a second, someone could touch that could cancel, right? You could cancel that animation. You would need to stop that animation, right? Does that make sense? So for example, let's say, I don't know. Can anyone think of an example?
Like you have a coin and you spin.
Perfect. You literally like, it's like animating, right? It's spinning, but someone taps something. You want the animation to stop. In fact, sometimes like what often happens is, let's say it's almost like a cancellation, right? You want almost like the animation to go in reverse. So what you would do is you would have to cancel that animation, and then like send it back to its original state, right? So this is actually really important because it complicates things dramatically, because right now everything is nicely like put inside this like one function, but again, as animations become more complicated and you have a much more interactive app, you have to create higher levels of abstraction, right? Because now you're receiving touch points that will cancel an existing animation. So, okay, let's do that. What I'm going to do is I'm going to create, I'm going to add another button here. I'm actually going to change this to a linear layout just for this purpose, just so we can have them next to each other. Okay, so this is button animate and button cancel. Okay? Okay? Okay. So what I'm going to do is I am going to put a member variable right now called current animation. And I'm going to remember that, right? Actually, let's basically just say, yeah. So this is not how you would code it up in real life, but I just want to show you how it would work, right? We'll talk about this a little later. Find view by ID, r.id button cancel. We already know it's a button, and I don't think we need to keep a reference to this, so let's just call set on click listener here. Okay. So what I'm going to do is I'm going to check if current animation is not equal to null, and current animation cancel. Okay? Okay, so in order to actually see this, let's increase this duration by, I don't know, 10 seconds. Okay? 10 seconds. Ready? It's gone. Cancel. Right? Let's go on some more. Cancel. But you guys understand, right? Like, so what oftentimes you do is if you have complicated interactions, so you can imagine that what we're going to get to later is we're going to start dealing with gestures and stuff like that, right? We can imagine as people are gesturing, you also have animations going on. You're going to have to keep track of what's currently being animated. Let's say you only want one animation to run at a time. You can imagine like you have a separate abstraction where you're saying, okay, I have my current animation. This current animation, whenever I change like behaviors in the activity, I need to cancel it and start a new animation, for example, right? You don't want both animations to like one to be already running and then another one to come in. You should always think about like canceling, and then that obviously complicates the coding. So animations can actually get very complicated when you start to have a very interactive app. Cool. Does that make sense? Okay. 5-minute break, and then we'll talk about the crappy view animations that we use to animate between activities. Okay? Let's stop this.